Okay, in this section, we're going to talk about looking at small data sets and trying to determine if they're normally distributed. So the first thing we should talk about is the z-score calculation. So if we solve for x, so if we algebraically take steps to solve for x in this formula, if we multiply by sigma, we would get this expression, and then if you add mu to both sides to isolate x, you end up getting this equation, which you might remember from an algebra class. This looks a lot like y equals mx plus b, which is a linear equation. And so one of the important things is if you were to plot the observed values from any distribution, like we see down here, on the x-axis with what would be their expected z-scores if they're coming from a normal population, we should see that the data points would form a linear relationship, or like a very strong linear relationship. So that this is actually a graph of the 3-year-old girl's heights that we were looking back in the previous section. So let's try an example where we're given a small data set and we're trying to determine if this distribution's coming from a normally distributed population. So, okay, so we got this data in this table. It's a very small data set. It's only a sample size of 6. We've got it in order, in ascending order, over here in this table on the left. And so we're going to follow the steps in the box up top for the normality check with a TI-84. So we're going to enter the data first into list 1. Okay. So we press stat, edit, and then clear out anything in your list. And okay, so I currently have all this information, all the data into list 1 already. So the next thing we're going to do is we're going to go press second y equals. You're going to turn on plot 1, and you want to click the normal probability icon, which is that last one. So you'll see it on the notes. It's this last icon. And you want everything else in that picture on the notes to be as is. Data list L1, data axis should be the x-axis. And then after we do all that, then we want to hit zoom and 9 for zoom stat. And here we'll see our normal probability plot, which again, on the x-axis is the observed values, and the y-axis is the normal scores, or the expected z-scores, if this distribution is coming from a normally distributed population. Okay, so we can see, like, once you hit trace, and then you can use the arrow keys to move between the points. So you'll notice the x values are the observed data values, and then the y values are the normal scores. So these are the expected z-scores if it's coming from a normal population. So we'll put this into the table below. And then you'll notice that there's symmetry with these normal scores. They end up having the same y coordinates, just the positive counterparts. And this will be true for any distribution you're looking at when you plot when you create the normal probability plot. Okay. So the next thing to do is to figure out if there is a linear relationship happening here. So you might look at this graph on the calculator and say, it's kind of close. But remember, back in chapter 4, the best way to determine if something is linear is to get the R value, the linear correlation coefficient. So we're going to do that next. So in order to do that, we have to put these normal scores into list 2. Okay, so we go back to stat, edit, and we're going to put these values in. Okay, so after that's done, just like the formula chart says under chapter 4, we hit stat, arrow over to tests, and then go down to linear reg t-test, hit enter, go all the way down to calculate, hit enter, and it'll output the R value. Okay, so the R value is 0.967. Okay. So the linear correlation coefficient between the observed values and the normal scores from the data in the table is 0.967. And so the next part is to compare this to the critical value in under the chapter 7 part of the formula chart. So our sample size is 6. And so let's find the critical value. So let's look at the formula chart. So under chapter 7, we'll see the critical values for a normal probability plots. Okay? So anytime we're using normal probability plots, we want to use this table that's under chapter 7. So if we look at a sample size of 6, the critical value is 0.888. So as long as our R value is higher than that critical value, we can say that this sample size is coming from a normally distributed population. Okay, so because the correlation coefficient is greater than the critical value, right, 0.967 is greater than 0.888, it is reasonable to conclude that the finishing times of Barbie's Bomber and the 5/16 mile race are approximately normal. Okay, so let's do one more example of using a normal probability plot. So this example, we got a sample size of 8. Okay, data's already in the table for us in ascending order. And we want to get the normal scores first, or the expected z-scores as they're otherwise known. So I've already got I went to stat edit, put the observed values into list 1 as you can see in my calculator. And the next thing to do is to go to second, y equals, turn on the plot, but it's probably already turned on from the previous example that we did. Make sure that last normal probability plot icon's highlighted, and then you can hit zoom 9. And here we go. So we can see all the observed values plotted with the y values being the normal scores. Now this time, I would say, just looking at the data set, that this does not look very linear. But again, the best course of action to take is to find the R value to determine it. So we're going to take all these normal scores. So we'll write them down in the table. Again, just make sure they match up with the correct observed value. And then because of symmetry, I don't have to go look at the other points. I'm just going to put the positive values from what I wrote down on the first 4. Okay, now I have to go back to stat, edit, and place these values into list 2. Okay, so I've put all the normal scores into list 2, and then time to get the R value. So we're going to press stat, arrow over to tests, and then go down to linear reg t-test, hit enter on calculate, and we can see the R value, 0.895. Okay, so we have to compare this to the critical value for a sample size of 8. So we're going to go to the formula chart, and sample size of 8, critical value is 0.906. right. Okay, so to answer their question, is it reasonable to treat the sample from a treat this as a sample from an approximately normal population? So the answer to that is no, because the R value is less than the critical value. So we can cross off B and C. And then if we analyze A and D's wording, the answer should be D. So D, no, the correlation between the expected z-scores, right? This is also the same as the normal scores. And the observed value, observed data was 0.895, does not exceed the critical value, right? Is not more than the critical value of 0.906. Therefore, it is not reasonable to conclude that the data came from a normal population.